PR.3 Functions. Southwestern College, Professor Maria Olivas. PR.3 Functions. Our first topic in differentiation will be to find limits of functions. In order to evaluate and understand these limits, we need to remember all of our algebra work with functions. In this supplement, we will review the following: function notation, evaluating functions, graphing functions, domain of a function, and applications of functions. 1. Function basics. Function. A function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. Some examples of functions are y equal to 2x, or we could also write it as f of x is equal to negative 1/2 x plus 4. Notice the difference between our notation here from our first linear equation to the second linear equation that I wrote. In the first one we have y equals, where in the second one we have that function notation of f of x. And another example would be g of x equals x cubed plus 2x squared plus 1. Evaluating functions. Substitute the given value into the function to obtain the output value. Example 1. Given f of x equals negative x squared plus 3x plus 1, evaluate. A. F of negative 2. If I want to evaluate f of negative 2, I'm going to need to substitute x equal to negative 2 every time I see an x. So f of negative 2 is going to be equal to negative, we're going to open up a set of parentheses, negative 2, close the parentheses, raise to the second power, plus 3 times negative 2 plus 1. Therefore, f of negative 2 is going to be equal to negative times 4 plus 4 times negative 2 plus 1. F of negative 2 is going to be equal to negative 4 minus 6 plus 1. F of negative 2 will equal negative 10 plus 1, and therefore f of negative 2 will be equal to negative 9. Now remember, when you evaluate a function, yes, our answer here for evaluating the function is going to be f of negative 2 equals negative 9, so I'm going to box that in, but that this also represents an ordered pair on the graph of this function. So the ordered pair for this would have been negative 2 comma negative 9 if I wanted to plot that point. I'm going to draw a vertical line segment separating here the work for problem A and problem B. For B, we're going to evaluate f of x plus h. This time we're going to substitute the entire quantity of x plus h. So I'm going to write down f of x plus h is equal to negative. We're going to open up a set of parentheses. I'm going to write x plus h, close the parentheses, and I'm going to raise that binomial to the second power. And then outside of that, we're going to add 3 times the quantity x plus h, and then we're going to add a 1. So f of x plus h is equal to negative. I need to square that binomial, so I'm going to write, I'm going to open up a set of square brackets. I'm going to multiply x plus h times x plus h, close the square brackets, and then we're going to add 3 times the quantity x plus h plus 1. F of x plus h is going to be equal to negative times, if I multiply x plus h times x plus h, we're going to get the perfect square trinomial x squared plus 2xh plus h squared. And I'm going to close the parentheses there. We're going to have to remember to distribute that negative in front. 3 times the quantity x plus h, and then we're going to add a 1 at the end. This is going to be f of x plus h equals, if I distribute the negative, I'll get negative x squared minus 2xh minus h squared plus, now I'm going to distribute the 3x plus 3h, and then at the end we add that plus 1. I'm going to box this in. This is my final answer because there are no like terms that I can combine. Example 2. Evaluate each function for the given value. A. M of x is equal to x divided by x plus 2 at x equal to 0.5. So m of 0.5 is going to be equal to 0.5 divided by 0.5 plus 2. This is going to be equal to 0.5 divided by 2.5, which is equal to 1 over 5, or 1/5. So I'm going to write m of 0.5 is equal to 1/5, which is also equal to 0.2, or 2/10. I'm going to box that in. That's going to be our answer. I'm going to draw vertical line segments separating the work here from 2A from 2B. So now on the right hand side of the vertical line segment, we have B, m of x equals x over x plus 2, and we're evaluating this at x equal to -2. m of -2 is going to be equal to -2 divided by -2 plus 2. If I simplify this, I'm going to get that this is equal to -2 divided by 0. Because I get -2 divided by 0, I know that I am not allowed to divide by 0, and anything divided by 0 is undefined. So I'm going to go ahead and write m of -2 is equal to undefined. And I'm going to box that in. Example 3. The number n of cars produced at a certain factory in one day after t hours of operation is given by n of t equals 100t minus 5t squared, where 0 is less than or equal to t and t is less than or equal to 10. Evaluate n of 4 and provide a verbal explanation of the meaning of n of 4. Let's begin by evaluating n of 4. n of 4 is equal to 100 times 4 minus 5 times 4 squared, which is equal to 100 times 4 minus 5 times 16, which equals 400 minus 80. This is going to be equal to 320. So n of 4 equals 320. Now I'm going to go ahead and box that in. But remember that we also need to provide a verbal explanation of the meaning of n of 4. So this means after 4 hours of operation, 320 cars were made. I'm going to box that in. Two, domain range for functions. The domain of a function is the set of all x values for which the function is defined. The range is the set of all y values. Example 4. Determine the domain and range of f of x equals 5x. So I'm going to go ahead and draw a graph for this. This is going to be a linear function. I'm going to plot the y-intercept first at 0, 0, and then I'm going to use the slope. I'm going to go 5 up and over 1 to the right to come up with another point. I'm going to label the 2 points that I used to help me sketch my graph. So the first one was the y-intercept at 0, 0. The second one was at 1, 5. I've extended my line through the 2 points to the ends of the coordinate plane. I've drawn arrows on the ends of my line. I have labeled the line with the equation y equals 5x, which is the same thing as f of x equals 5x. And I have also gone ahead and I have drawn a negative infinity symbol on the left-hand side of the x-axis and a positive infinity symbol on the right-hand side of the x-axis to help me come up with a domain. The domain is all the x values, and since I can see here that my function has an arrow that goes all the way towards the left and towards the right, that means that it's going to be all real numbers for our domain. We can write that domain as the open interval from negative infinity to infinity, or the set of all x such that x is an element of the set of real numbers. As for the range, because this function goes down towards negative infinity for the y values and goes up towards positive infinity for the y values, this is also going to mean that our range is going to be set of all real numbers. We can write the range in interval notation as the open interval from negative infinity to positive infinity, or in set builder notation as the set of all y such that y is an element of the set of real numbers. 4. Piecewise defined functions. A piecewise defined function is a function that is defined differently on different parts of its domain. Example 7. Given the piecewise function f of x equals x plus 3 when x is less than negative 3, and f of x equals 2x minus 1 when x is greater than or equal to negative 3, evaluate the following. For a, we're going to start off by evaluating f of 2. So in order for me to evaluate f of 2, I need to look at the inequalities and determine which piece of this function am I going to be substituting into. Since 2 is considered to be greater than or equal to negative 3, and I've circled that inequality, I'm going to be using the part that says f of x equals 2x minus 1. So that means f of 2 is equal to 2 times 2 minus 1, which is equal to 4 minus 1, which equals 3. Therefore, f of 2 equals 3. And I'm going to box that in. B. F of 0 equals 2 times 0 minus 1, which is equal to 0 minus 1, which equals negative 1. So f of 0 equals negative 1. And I'm going to box that in. And I'm using the exact same piece from before because 0 is greater than or equal to negative 3. C. F of negative 2. F of negative 2 is equal to, I'm continuing to use the same piece of the function because negative 2 is greater than or equal to negative 3. So it's going to be f of negative 2 is equal to 2 times negative 2 minus 1, which is equal to negative 4 minus 1, which equals negative 5. So f of negative 2 is equal to negative 5. D. F of negative 3. F of negative 3, once again, I've circled that same inequality that we've been using because that's where it falls. It falls in that interval. So f of negative 3 is greater than or equal to negative 3. So we're going to find f of negative 3 by substituting into that 2x minus 1 part. So we're going to have f of negative 3 equals 2 times negative 3 minus 1, which is equal to negative 6 minus 1, which equals negative 7. So f of negative 3 is equal to negative 7. I'm going to box that in. E. F of negative 4. F of negative 4, we're finally going to be able to substitute into the first piece of this piecewise defined function because negative 4 is less than negative 3. So I'm going to substitute into f of x equals x plus 3 this time. F of negative 4 equals negative 4 plus 3, which is equal to negative 1. So f of negative 4 equals negative 1. I'm going to box that in. So I have evaluated this piecewise defined function at several values of x. Now we're going to graph this piecewise function. So G says graph the piecewise function. I'm going to draw a coordinate plane. So first I'm going to draw my vertical y-axis extended to the ends of my graph here and draw arrows at the ends. And then I'm going to draw my horizontal x-axis extended to the end of the graph here, draw little arrows on the ends of my axis, then label each one of my axes. I'm going to label the vertical y-axis with a y and the horizontal x-axis with an x. I'm going to rewrite my piecewise defined function. F of x equals x plus 3 when x is less than negative 3, and 2x minus 1 when x is greater than or equal to negative 3. So looking at the two inequalities here, it says x is less than negative 3 and then x is greater than or equal to negative 3. I can tell here that the division is happening here at negative 3. So that's where I'm going to have like my division of my two pieces of my function here, because it's going to look like these two different functions depending on whether we're going to the right of negative 3 or to the left. For the first piece, where it says f of x equals x plus 3 when x is less than negative 3, because it's strictly less than, we're going to represent that piece there with an open circle where x is equal to negative 3 on that, for that piece. And for the second piece, where f of x is equal to 2x minus 1, it says x is greater than or equal to negative 3 because it has that equal sign there, and I've circled it, and I've drawn an arrow pointing at it, and I wrote the words closed circle because I'm going to have a closed circle. at x equal to -3 when it's representing that piece of that function. Let's begin by graphing the first piece of our piecewise function. So where it says f of x equals x plus 3 when x is strictly less than -3, I'm going to write down y equals x plus 3, and then I'll put a comma, and then after that I'll write the x is less than -3 part. So to me, when I see y equals x plus 3, to me it looks like a simpler equation. It looks like it's easier to graph. I know what the y-intercept is, I know what the slope is. So if I were to plot this line, I would just go to 0, 3 on the y-axis, plot my ordered pair there, my point, and then my slope is 1. So from this point I would go up 1 and over 1 to the right. I would connect these 2 points with a line that goes all the way through to the ends of my graph with little arrows on the ends of those lines. But I know, because this is a piecewise defined function, this is not what this function is going to look like. I know that I only have these values where x is strictly less than -3, where this is going to be true. So I go to -3 here, I erase everything else that is to the right of x equal to -3. Because those are the values that are greater than or equal to -3. And I'm going to draw an open circle where x is equal to -3. To know exactly where that ordered pair is at, I'm going to substitute -3 into this equation. Y equals -3 plus 3. This equals 0. And then I drew an arrow to the right, and I wrote down the ordered pair -3, 0. So at -3, 0, I've drawn an open circle. And I know the slope is 1. So I have gone down 1 and over 1 to the left to come up with another point at -4, -1. I have connected those two ordered pairs, and I have drawn my line going to the left-hand side of this coordinate plane, extending it to the end on that side, on the left-hand side, and I drew an arrow there. The next piece is going to be y equals 2x minus 1 when x is greater than or equal to -3. I've drawn a horizontal line segment to separate the work that I did for the y equals x plus 3 part, and to separate it from this work for the y equals 2x minus 1 part. So this one, once again, if I were to imagine that I were going to graph the line y equals 2x minus 1, I would just go and start off. This is already in slope-intercept form. I would start off by going to 0, -1. I would draw my y-intercept point there at 0, -1, and then I would go ahead and use the slope, which is 2, so I would think of that as 2 over 1. I would go up 2 units and over 1 to the right, so I would label my y-intercept at 0, -1, and the next ordered pair I would get from my slope would be 1, 1. And I would come up with one more point here, so I would move over, instead of going up 2 and over 1 to the right, I would go down 2 for my y-intercept and over 1 to the left. And then I go again for another point, down 2 over 1 to the left. And then I go again down 2 and over 1 to the left until I landed right at x equal to -3, because I know that my line, or my ray in this case, is going all the way up to x equals to -3. And I'm going to have a closed circle where x is equal to -3. So I have connected the points and extended my ray to the right-hand side of x equal to -3. I have labeled that point at x equal to -3. To get the exact point, you could actually substitute that into the equation, y equals 2x minus 1. So y equals 2 times -3 minus 1. Y is equal to -6 minus 1, which is equal to -7. So my ordered pair is at -3, -7. And there is my piecewise defined function.